Question 20 reads, a student places two wires parallel to each other and sends equal currents through both wires in the same direction. What observation will the student make? So in this question we're going to talk about what happens when these two wires are traveling in the same direction and in opposite directions, just so that you can be aware of both. So we're going to cover the same direction first because that's what the question is asking. But what I want you to see below is that we have our two wires, and then in sort of this three-dimensional sort of image we have our first and second wires also. And so what we're going to do first is draw the magnetic fields around these wires, because based on the magnetic field we'll be able to tell what direction the force will be, which direction the force will be in, and then we can see whether or not this force causes these wires to attract or to repel. And so if you're just focused on the second wire first, so I want you all to look at the second wire. I want you to determine what direction the magnetic field will be. So if you use the right hand rule, you can put your thumb to the right. So your thumb goes to the right, and then we'll see that what I want you to do is imagine where the magnetic field will be at this point across from the first wire, because if we want to find the force at this point, the force on the first wire here, then we need to extend our magnetic field this far. So if we were to put our thumb into the right, then our four fingers are going to be extending out of the page. So we're going to put a sort of dot right here, and you can imagine this below. You have your thumb in the direction to the right, and you'll see that your four fingers will actually want to extend out of the page here. So that means now what I want you to do is focus entirely on the first wire. Just pretend that the second wire isn't there anymore. So now you know that the magnetic field at the first wire is coming out of the page, and your thumb, you know, is in the direction of the current. So now you go ahead and do that. And so if you put your thumb in the direction of the current and your four fingers extending out of the page, you'll see that your palm is actually facing you. So that means that because the force extends out of the palm, then the force from the second wire to the first wire will be pulling, basically. So it's going to be an attractive force. And then so now what we want to do is do the same thing, but this time focusing on the first wire to the second. So we're going to look at the magnetic field of the first wire at this point, opposite of the second wire. And so we're going to put our thumb in the direction of the current, and we'll see that the force is actually extending, or the magnetic field is actually extending out of the page, or I'm sorry, into the page, because when we wrap our fingers around in this way, we'll see that the magnetic field is going into the page. So now if you completely disregard the first wire now, and you just focus on the second wire, and you put your thumb in the direction of the current, and then you put your fingers in the direction into the page, then you'll see that the palm of your hand is actually facing away from you. And so that means that the force is going to be, once again, traveling this way, and so you're going to have basically two attractive forces. So that means if you have wires traveling in the same direction with equal magnitude of electrical current, then these forces are going to be attractive, and so the wires are going to attract to one another. So your answer for 20 is actually going to be D. But next we're going to talk about what happens when you consider two wires in the opposite direction. So once again we're going to label this as the first wire and the second wire. And so we're going to focus primarily on the second wire first, and then we're going to see where the magnetic field is at, if it's going into the page or out of the page beyond the first wire. So here we have our second wire, and we put our thumb in the direction of the current, so that means our magnetic field is going to be going into the page. So that means our magnetic field here is into the page. And so if we now just focus entirely on the first wire, just cover your hand over the second wire so you don't even see it anymore, then we know that the magnetic field is into the page, and our thumb should be going to the right. And so that means that the force from the second wire to the first wire is going to be traveling away. So it's going to be a repulsive force that the second wire has on the first wire. And so now you can do the same thing, but focusing on the first wire to the second wire. So we want to know what the magnetic field is, whether it's into or out of the page at the point opposite of the second wire. And so we put our thumb in the direction of the current, and we can see that the magnetic field is going to be into the page at this point. So it'll just basically look like this. And so we have an X corresponding to into the page. So now cover your hand over the first wire and focus now just on the second wire. So now if we imagine that the magnetic field is into the page and our thumb should be in the direction to the left for the second wire, then we know that that our force is going to be extending towards us in this direction because our palm is facing us. So now we know that whenever wires are traveling in opposite directions, they have a repulsive force on one another. So you can, if this doesn't make sense, then you should at least know that whenever wires are traveling in the same direction, they have an attractive force, and whenever they are in opposite directions, they have a repulsive force.